Hey there, Stat 200. This office hour, we're going to be talking about association between categorical variables, and the test we use there is the chi-square test. We only have really one question about this. This is more about interpreting tables and what we see. It's kind of almost like a refresh on what we were talking about in the probability lesson. So let's get right to it. You'll see what I mean. And I'll just show you kind of the new content later on in this office hour. Alright, so the table above shows the opinions of 953 respondents in the General Social Survey to the question, if your party nominated a woman for president, would you vote for her if she were qualified for the job? What percent of respondents who said yes to voting for a woman president were male? So yeah, this should kind of harken back to our time in probability. So let's just reread this line. What percentage of respondents who said yes to voting for women, so we're only looking at people who said yes, right, were male. So what percentage of this column is male? And the way you're going to find that is you're going to say, oh, okay, well, 335 of them were male out of a total of 823. And it's that easy. It's just going to be 335 divided by 823. Okay? And then you can just easily go to the calculator, find out that comes to about 0.407. Or you could also say 40.7%. Now these are going to be multiple choice questions, so you're going to see. You'll know which one is correct once you get your calculator out. Alright? That easy. Let's do a couple more. The table above shows the opinions of 908 respondents in the General Social Survey to the question, do you believe there is life after death? What percentage of males believe in life after death? What percent of males believe in life after death? Right, so now we're going to be looking at just males, right? What percent of males, right? So we're just going to look in this row here, only interested in males now, believe in life after death. So, again, males who believe in life after death, there are 282 out of a total of 391 males. So we're going to divide again. Just 282 divided by 391. And we, again, can go to our calculator, and what we're going to find is that that's equal to about 0.721, or 72.1%. Right? Does that make sense? Again, this should be familiar from when we were talking about probability earlier in the course. Alright, and then I wanted to juxtapose this question with this question because they're very similar. We're using the same data set, but now we want to know what percent of respondents who believe in life after death were male. So it's kind of like we've flipped things around from this question. It says percent of males believe in life after death. What percent of respondents who believe in life after death, this column, were male? Well, now we're going to take 282 again, but this time we're going to be dividing by the total number of people who believe in life after death. That's 690. And we go to the calculator, and we find that that's approximately 282 divided by 690, about 0.409. Sorry about that. Got a little carried away with my zeros. 409, or 40.1%. Okay? So that just shows you how it's done. I went through these kind of quickly. But if you find yourself unsure how it happened, you can watch it again. Or if you'd like to see further examples, please don't hesitate to give me an email. Alright, let's move on to some of the new content, where we're actually going to look at some chi-square results. Alright, so the table above shows the opinions of 321 respondents from the General Social Survey by whether they owned a gun or not, and whether they favored or opposed a law requiring a permit to own a gun. So what's the correct null hypothesis for the survey? So this data is all nice and good, but we're actually not going to be using the chi-square output here. I mean, that's great, good information to have, and I can talk about the interpretation of that after we come up with the correct answer. So the correct null hypothesis. Now remember, whenever we're talking about hypotheses, they're always about the population. I know I sound like probably a broken record if you've listened to the other office hours. I hit this point multiple lessons, and I say it a lot. Whenever we're talking about hypotheses, they're always about the population, right? Always, always, always. So that kicks these two right out. And now the two options we have left is there is no relationship in the population between gun ownership and opinion regarding gun law permit, or there is a relationship in the population between gun ownership and opinion regarding gun law permit. So, null hypothesis. Remember, null means nothing, right? It means nothing's happening, nothing exciting is going on. So we should always think of it as there's no relationship, there's no association, there's no significant difference in any category. So that makes it pretty easy to decide, right? It's that there is no relationship in the population between gun ownership and opinion regarding gun law. Two important things: no relationship, that corresponds to the null, and then population, that corresponds to all hypotheses. Okay? Now, going back to this table and taking a look at our output here. Now, we said the null hypothesis is that there is no relationship in the population between gun ownership and opinion regarding gun law permit. So the alternative hypothesis is that there is a relationship, right? So we look at this p-value, and usually, if we don't state explicitly, we're going to take a significance level of 5%, or 0.05. Now this p-value is less than that significance level, so that means we can conclude in favor of the alternative hypothesis. We can reject the null hypothesis, which suggests that there is a relationship between people who own a gun and people who think that there should be a permit required to own a gun. And that's pretty much what we expect, right? That makes a lot of sense. People who own a gun maybe don't want to have to be required to have a permit for it. I'll leave it there. Politics behind. That's how we can interpret this. Alright. Which of the following is the best statement of the alternative hypothesis for conducting a chi-square analysis? Now again, this is another one of those questions where I'm asking you about the wording of a hypothesis. Right now, this time I'm asking about an alternative hypothesis. Before I was asking about a null hypothesis, so just try to get this wording straight. Keep it in mind. And just to revisit this again, whenever we talk about hypotheses, are we making statements about the population or the sample? It's going to be the population, right? We don't have any need for a hypothesis about the sample because we actually know everything about the sample. There's no sort of inference. None of that needs to happen for the sample. We have all the information. But whenever we're making hypotheses, we have to make it with regards to the population. So that breaks it down to these two. Variables are not statistically related in the population. The variables are statistically related in the population. Now remember when I said the null hypothesis, I said there's no relationship, nothing special is going on, so that's not statistically related. So therefore the alternative hypothesis is just the converse of that. The variables are statistically related in the population. Alright, so I know I sound like a broken record, but this is a very important concept, and I keep including it in these office hours because I keep seeing people getting it wrong. So, please, try to remember, hypotheses are about the population. Null means nothing statistically significant is going on. Alternative is that, yeah, there's something statistically significant going on. Okay, move on. This one's a little tricky, I think, because oftentimes people forget what an odds ratio is. So, the table above summarizes by gender of respondent the responses from 1,033 people to the question, do you smoke? What is the odds ratio for women smoking to not smoking compared to men? Okay, So the odds ratio. So let's just call this the odds ratio. That's the odds of smoking for women. So odds of smoking for women divided by the odds of smoking for men. I'm writing this out because I think it's easier to do when you kind of interpret this. Now, when we're looking at odds, usually when we're looking at tables like this, we calculate what we refer to as risks. So the risk for women smoking would be 171 divided by 589. Odds, however, are the chance that it is happening divided by or the number of times that it is happening divided by the number of times that it's not happening. That's what that means. And now we're doing an odds ratio for women, so that's why we're putting that on top. It says for women compared to men, so whatever it's compared to is going to be in the denominator, on the bottom of your fraction. And the women smoking is going to be on top. That's what we're going to be comparing to. So, odds ratio for women, let's just find the odds for women smoking. Now, we're only looking in this column, or row here. So the odds for women smoking is 171 divided by 418. 171 divided by 418. And that's going to be divided by the odds of smoking for men, calculated in a very similar way. It's 142 divided by 302. So, 142 divided by 302. And now we can plug this into a calculator. It may be helpful for you to try to do each step individually. So first find this fraction, put it up here, or like find the decimal form of this fraction, decimal form of this one, and then divide the two. It's probably just easier, because otherwise people start throwing around parentheses and they forget, and then they get a wild answer, and it's just not so good. So I'm going to go to the calculator. I'm going to find these first, and then we're going to divide those two, and we're going to find the final answer. So first, we're going to find that the odds for women is about 0.409, and the odds for men is about 0.470. Now we go back to the calculator, and we're going to divide those two now. So 0.409 divided by 0.470 gives us an odds ratio of approximately 0.870. So that is how we get that odds ratio. It's a ratio of ratios, kind of. We're going to find the odds of smoking for each group, and then just divide. And that one trips a lot of people up. So, little word of warning. You might see this one. Okay, we're almost done. This is our last one. So we've got this death penalty opinion. Table above shows the opinions of 1,447 respondents to the General Social Survey to the question, do you favor or oppose the death penalty for persons convicted of murder? The purpose of examining the data is to see if there is a gender difference in how people would respond to this question. To test whether there is a relationship in the population between gender and support for the death penalty, the chi-square statistic equals 20.9, and the p-value is less than 0.001. Are the results statistically significant or not statistically significant? State your conclusion. Now, again, when we don't give a significance level, it's pretty safe to assume that it's 0.05 or 5%. So this one doesn't explicitly state it, but it also gives us a super low p-value. So for pretty much any reasonable significance level, the conclusion is going to be the same. Now, what I'm saying here is that the p-value is less than the significance level. If you can keep that in your head, now that means that we're going to reject the null hypothesis. Okay? So let's read these conclusions and figure out which one is the one we want to choose. So either we have two options here that say the results are statistically significant, and then it says that there is a relationship, or there is not a relationship. And you say they're not statistically significant, there is a relationship, or there is not a relationship. So this is all about, this is testing on two things. One, is it statistically significant? Two, when you decide that there is statistical significance, are you saying that there is or is not a relationship? So let's answer these in order. Is there statistical significance? Well, the p-value is less than any reasonable significance level. And that always means that we are going to reject the null hypothesis, which is another way of saying that we have statistically significant results. There are a bunch of ways to say basically the same thing. Rejecting the null hypothesis means that your results are statistically significant, and that means that there is a relationship. Those are just, it's hard to get these all straight in your head, but a null hypothesis says that there is no relationship, right? So if we're rejecting the null hypothesis, we're saying, oh, well, there is a relationship, a statistically significant relationship. So now, thinking about what I've just said, we know that we need to narrow it down. These two can't be correct. They both say that they're not statistically significant, but we have a very low p-value, so it is statistically significant. And the conclusion is that there is a relationship or that there is not a relationship between opinion about death penalty and gender. Like I was just saying, when we reject the null, we're saying that there is a relationship because the null hypothesis says that there is not. So therefore, the answer must be this one, the first answer listed. The results are statistically significant because of our p-value. The conclusion is that there is a relationship between gender and opinion about the death penalty. That's all we're saying. I mean, we talked about it earlier on, what the null and alternative for the chi-square test are. The null is that there's no relationship between the variables. The alternative is that there is a relationship between the variables. And really, that's all we're doing that's different this time. We're not really going to get into the nitty-gritty of how to calculate the chi-square statistic. We just don't have the time. We're going to have Minitab do it for us. And then Minitab's also going to give us a p-value. So really, it's interpretation of p-value and then understanding how the null and alternative hypotheses appear, or how you can think of them conceptually in this framework. Okay? So not a super tricky lesson. Usually people do pretty well on this one. But if you do have any questions, please feel free to give me an email, or if you'd like to meet in the virtual office, please, we can set up some kind of meeting time. That'll work out so we can kind of straighten this out. All right? Good luck on this lesson, and I'll talk to you next office hour.